we went through the homologous series. So now we are going through bond fusion or cleavage, or also called as breaking. Before looking that, we should have to know some meanings of some symbols. This is fish hooked arrow. It indicates the transfer of one electron. And this arrow indicates the transfer of two electrons. So please note that. Bond fusion is of two types: homolytic and heterolytic. In homolytic fusion, we have some reactions like that. There is a formation of free radicals, neutral free radicals. We know that the one bond is formed by two electrons. In homolytic fusion, the one electron is withdrawn by these molecules, and there is a formation of neutral free radicals. In heterolytic fusion, both two electrons get attracted by single species, and there is a formation of positively charged cation and one formation of anion. This is called as positively charged, called as carbocation, and one is negatively charged, called as carbanion. So there is a AB compound. Suppose B is more electronegative than A. So what is electronegative mean? The element which has more tendency to get negative charge. So in homolytic cleavage, it gives homolytic cleavage. There is a formation of free radicals. But in heterolytic cleavage, there is a formation of cation and anion. So you will think that what are the conditions to perform homolytic and heterolytic cleavage. So we will be looking. Homolytic fusion is favored by nonpolar solvent. heterolytic cleavage is favored by polar solvent. Also, homolytic cleavage is occurred when the two species have similar electronegativity or small electronegativity difference. Small electronegativity difference. Heterolytic cleavage occur in the substance having more electronegativity difference. Homolytic fusion uh, is also favored by some reaction initiators like peroxide, H2O2, benzyl peroxide, etc. And heterolytic fusion occurs at high temperature. Also, homolytic fusion is get easier in the presence of UV light. We have to look some examples of these reactions, like we are to in presence of UV light, in presence of sunlight use Br free radical. Also Cl2 gives also this free radical. And some examples of heterolytic fusions are this is chlorine compound. They have more electronegativity difference, so the positive charge is went to carbon and the negative charge is went to chlorine, because chlorine is more electronegative, so it gains 2 electrons, 1 electron from carbon and one is of its own. And one compound I have to say. So here we can see there are many bonds. One CH bond is there, CC bond is there, CO bond is there, and also OH bond is there. But we have to make the bond which has more electronegative difference. So here we can clearly see the OH bond has a more electronegativity difference. Yes, so we can, the compound will be this. Thank you.